Let's wait for everyone to join in the meeting first. Let's wait for 5 to 10 minutes so that everyone can join. I don't think so there is anyone here now. Hi, yes, just wait for others so that we can start after that. Please wait for a few more minutes and then we will start. Okay, we can start now. So I just share my screen. Um, wait a second. Yes. Can you see the screen? Okay.
Yes, sir.
All right. So the today's topic we are going to discuss is the approximation of the functions, like how you fit a function. So I just show here. Where is that? Yes. So you are approximation of function, right? So if you are given a kind of complicated function, something like this, which is f of x, how would you approximate it using like a linear curve or a kind of this type of curve or something like very smooth curve? So there are different types of ways you can do that, depends on the values of f. So given f at x naught x1 up to xn, you have to find a polynomial first which fits f at these points. Okay, so you have to find such type of polynomial. This is your first task that you have to see. So from here if you go, then you see So f of x is some unknown function. You can see the values if you see my cursor here. So x and f of x, right? Then you have to find a polynomial which fits f at these points, okay? So this one comes with the what we call as Lagrangian polynomial. I think if you have seen in your lecture notes, yes. So at these points, x naught, x1, x2, x3, you define f at x naught as f naught, x1 at f1, like these. So x2 as f2, like this you define. And then you just use, yeah, so P3x is for cubic. So I'm not deriving like how this is coming, but you can just verify it like how this is coming. So this is P3x is a polynomial which fits f. So f naught, f1 and f2 and f3 are given to you already. So you just need these type of coefficients for that. X minus x1, x minus x2, x minus x3, and this. So you have to use this formula just to find out the polynomial approximation. And what type of degree is it? So if you are having like 4 points, then you expect it to be a 3-degree polynomial. If you have like 5 points, then it would be a 4-degree polynomial, and so on. So x into x into x is like 3 degree, right? So we just try one thing over here. This is what, okay. So fit the cubic through first 4 points of the table and use it to find interpolated value for x. So if I go and take some random values, let's say, I just write here. So, so find a cubic, no, I just take a quadratic to be easier for me. Find a quadratic polynomial that fits f at 3 points. Because it's quadratic, so it will fit f at 3 points, and that will be your you say it is Lagrangian polynomial, okay? Right. So if I'm given the values like 1, 2, 3, this is your x naught, x1, x3, x2, and f naught, f1, f2 as f naught, f1, f2. Say, what is this? 4, 5, 4, 5, 7, kind of this. Then how do you use this formula? So you just, so your f is like this. 1 is like 4, 5 when it is 2, and 3 it is like 7, right? So it's kind of linear function. So it is your f of x. Then find a rad curve shows your, so f is given at these 3 points. So you just find a polynomial which match this. So rad curve is the polynomial which match these 3 points, right? So you are just filling the gaps in between the points. So it means that it's kind of interpolation. Inter means in between the points, you are finding such function which matches at these points, right? So that is called as interpolation. Okay. So if you move out like if I want to find out, if you want to extend these curves further ahead without knowing the value of the function after these points, then it is called as extrapolation in this case. Okay, just mind this difference. Extrapolation. Okay, so for this you just need to use the formula which says that p2x, which is just x minus x naught, x minus x1, x minus x2, I think. Is that true? No, it should be, wait. Yes, it should be x naught, x1. It should not go beyond this. So, and you leave x naught behind, so it's not correct actually. So you just write x minus x1, x minus x2 divided by x naught minus x1 and x naught minus x2. And this is your f1, f naught plus x minus x naught, x minus x1. You keep, the trick is just remove your x1 in this case, just omit your x1, x naught in the first case, and they take x1 minus x naught, x1 minus x2, and f1 like this. And similarly you have again same x minus x1 and x minus x naught, keeping x2 left, and again x2 minus x naught, x2 minus x1. This will be your f2. So you just substitute these values over here of f naught, f1 and f2, like 4, 5 and 7. So just substitute here if you want to. So in place of this, just substitute that, and you will get an expression of p2x kind of this form, which is ax squared plus bx plus c, where a, b, c are coming from a. This is your a, equation a, so they are coming from a equation. So p2x is your polynomial, right? A quadratic polynomial that you get from your function f. Is that clear, everyone? Any doubts? I think it's just a basic, the formula that you have to use. But if you have to learn how this formula is coming, that would be interesting. Um, okay. So here, these may not be like x naught, x1, x2, x3. You don't expect to be equidistant. It means they can be anything, okay? Like 1, 5, and 6, 9. They can be anything, right? So we do not assume uniform spacing, okay? All right. So this is what I want to tell. And if you have like, if you have like n points, then n minus 1 degree polynomial. If you have n plus 1 points, then n degree polynomial would be the case in this situation. All right. So the next question typically comes into mind is, what's the error of interpolation? So I just show that and try to solve one question based on that. I think there is one. Okay, there is nothing, but I show you basically on this. There may be questions on this, so I will show you what type of questions can be asked. So if you have function and p and x, you can easily find out the difference between your function and p and x by counting the roots, like x naught, x1, xn are your satisfied roots. So you can write down like this, and ultimately you end up with an expression of an error function, which is this: x minus x naught, x minus x1, x minus xn, and this. So sometimes in the question they may ask you like, what is the error bound? So I just write here. So wait a second. So the question is, if p and x is, what's the degree of this? I should say it's a n degree, n degree polynomial approximating fx, right? N degree polynomial approximating fx, f of x, then find the error bound. Find the error bound basically. So the error is given by, in this case, here x is just x minus x naught up to x minus xn divided by, okay, so it is fn plus 1 xi by n plus 1 factorial, I think. That's, yes, so it's just the same. Yeah, so in the question they may ask you like, this bound and this bound, and you have to reduce it by some number, right? So you need to calculate maybe your function and try to find out its derivative. Like if n is 1, suppose it is cos psi, then you can bound it by 1, right? And you can bound these terms directly by their this term x minus x naught, x minus xn, and other term you can bound this by this, and this term you know what is to bound it. So in this case you can easily found your error bound, right? This one is your error bound. Is that clear, everyone? Okay. So sometimes this can be asked in your question and they will find out. So I'm just trying to give you one simple question, maybe how to do that. Just see, wait for that. Yeah, fine. Okay, so just try a simple question that I give now based on this little bit. Not exactly the same, but you can try. So the question is, given function f of x equal to under root of 1 plus x, let x naught is your 0, x1 is your 0.6, x2 is your 0.9. If Lagrange polynomial of degree 2, yes. Okay. Of degree 2 approximates your f, then find f.45 and absolute error. Just try this one. You know what is absolute error, so I'm not gonna tell again. Just try this question right first and then we will see. Okay, just try this. Yes, I think if you have tried it, just let me know. Okay, so in this you just need to find what is your P2. I just use P2x, right? Have you tried it, anyone? What is P2x? You haven't tried it then. Okay, so if P2x is that, then you just try to find out, because absolute error is what? Absolute error is what? P2 at 0.45 minus F at 0.45, right? That will be your absolute error, and this is the absolute value, right? So the difference between okay, so F at 4.45 and P2 at 0.45 will be your absolute error. And in this case, F at 0.45 is just under root of 1 plus 0.45, which is under root of 1.45. So you can easily calculate it, and you just try to find out what is P2 at this point, and then you are done. Okay, so I'm just giving you another question, which I will also solve if you want to try that. So question is, let f of x equals to under root of x minus x square and p2x be interpolating polynomial on x not equal 0, x1 and x2 equal 1. Find largest value. Find largest value of x1 in 0, 1, for which f of 0.5 minus p2 at 0.5 is your minus 0.25. So you just have to find the largest value of x1 for which this happens. So just give it a go and try to find out x1 in this case. So it's a bit different, but just try. All right, so I just go with that. So in this way, how do you deal with this? Find the largest value of x1 for which f at 0.5 and p2 at 0.5 is this. So in this way, you just try to, you know this, right? Ax naught plus, okay. So I just write ax square plus bx plus c. That will be your polynomial. And f at 0.5 you can easily calculate using this equation here. So f at 0.5 I just write directly like this, and this will be your minus 0.25. So you will get somehow expression of x1, like sometimes kind of c prime x1, and maybe some kind of this f.5 is equal to minus 0.25, and d is known, c prime is known, d d is also known, and f.5 is known. Then you can find c, find x1. Is this clear? Just use the definition of what is p2x. Yes, everyone, is that clear? If that's true, then we can move further away. Okay. So just remember this formula. By the way, I haven't given you any questions based on that, but the question may ask you like finding the absolute value of this function, like the pounds over it, in that way. All right, so we go with another method which is called as divided differences. Okay. So what, there are two disadvantages of using Lagrangian polynomial. First, it involves more arithmetic operations than does the divided difference method. So the problem with the Lagrangian polynomial method is that it does more arithmetic operations. Okay, so it's quite complicated to understand. So if you look at this expression over here above, it's kind of, it's kind of computationally expensive to do this, right? Every time you have to divide, multiply, right? So it's computationally expensive. And secondly, if we desire to add or subtract a point from set used to construct a polynomial, we essentially have to start over in the computations. So if you want to add or subtract a point from the set, then you really need to have to start over in the computations. It means that, so if I just show you here, so x0, x1, x2 are 3 points, right? So if you have to remove x2, suppose, then you have to remove x2 from here as well, and here as well. So it's kind of destroying all the polynomial. You don't want to destroy. You want to add some more terms. If you have more data, then you add more terms in the polynomial instead of destroying and changing it all. Right? Is that clear? Okay. So that's why divided difference came. So the idea is almost similar. So you have kind of points x0, x1, x2, x3, and immediately you have the values of f at x0, f1, and f2 and f3. So in this, you try to calculate what is the divided difference. So I just show you directly what's that basically. So the formula is this: fx naught plus x minus x naught fx naught x1. So I just write here. So divided difference. So again, you have point x naught x1 up to xn, f naught f1 up to fn. For example, n is 2. So I just show you x naught x1 and f naught f1. So the divided difference is p2x, which is approximating this thing, is fx naught plus x minus x naught fx naught x1. Okay, and what does it mean in this case? That I will show. So in this case, if you look at this definition, then fx naught x1 is basically your f1 minus f naught and x1 minus x naught. Okay, so fx naught x1 is just your f1 minus f naught divided by x1 minus x naught. And similarly, you can define fx1, I think, wait, fx1 x2. It's same as f2 minus f1 divided by x2 minus x1. And fx naught x1 x2 is this. Okay, so I just write here. So fx1 x2 is f2 minus f1 divided by x2 minus x1, and fx naught x1 x2 is your this is say b, this is a, b minus a divided by x2 minus x. If that's clear, this is very clear. Okay, so you know what is fx naught, you know this fx naught x1, then you can find out what is your p2x, right? In the same way, so just find out in this case what is this. Yes, so write the interpolating polynomial of degree 3 that fits the table 3.2 at all points from x naught 3.2 to x naught x3 4.8. So you can do kind of similar thing here as well. So just give it a go and try that. Then we will move to another errors and stuff. But I will show you. I just write the question. Use divided difference polynomial fitting f at 1, 2, 4, say, and 5, 8, 7. Just try to find out this, which is x and fx. Just try this and using this, of course, and I will check. And yes, all right. Yes, if you have tried it, I just show you. Yes. So it's just b2x, and you need to calculate f at x naught plus x1 minus x naught. Sorry, x minus x naught f x naught x1 and x minus x naught x minus x1 f at x naught x1 x2. Okay, so this means f at x naught is 5 plus x minus 1. F at x naught x1 is f1 minus f naught, so 8 minus 5 divided by 2 minus 1 plus x minus x naught x minus x1. X minus x naught is just 1, x1 is just 2. So why is that? Oh my god. Okay, this is amazing. Right, so then you just do f2 minus f1. So what is f2? fx1 x2. So it is basically 7 minus 8 divided by 4 minus 2. So I just write 7 minus 2 minus 8 minus 5 and overall 4 minus 1. Okay, this is all expression. Once you solve it, then you will get this expression of this. All right. So this is by divided difference of how much order? Can anyone answer this? Yes. Order is anyone from order? Like order is basically the error. How, what's the order of the error in this case? So you have 2-degree polynomial. So if you look behind, then the error has only like x naught up to xn terms. So here x naught, x1, x2. So order of error is 3. All right. So order of error is 3 in this case. So that's called as divided difference of order 3, like this. Okay, x not x1 x2. Yes, is this clear everyone? Okay, so if that's clear, then we go to another question. um, so you can calculate in this way, and there is another terminology, like if you already know, like if the x-axis is equidistant, means all the points are at equal position, you can replace it by this type of terminology. I think in lecture notes it's there. Not going to do that. Okay, so I think it's almost finished, so I may give you some questions based on that. Wait a second for that. So the questions can be asked basically from calculating this type of divided difference, fx not x1, right? Like this. So I just try to find out one question based on that. And this is also called as Newton forward difference formula. Just look at that because some questions may be asked on that basically. I'm just trying one question based on something. Just try one question. So if Newton forward difference formula is used to approximate f at point 3 for data x f x 0, 0.2, 0.4, 0.6 and 15, 21, 30, 51. Suppose f.4 is lower by 10 and f.6 was higher by 5, higher lower, then f.3 approximation changes by what? So in this question you need to find out what is like how the approximation of f.3 changes if f.4 and f.6 are changed. F.4 lower by 10, f.6 higher by 5. Just try this one. And yes, we just stand up to that. If you have any questions. Yes, if you have tried this, what's your approach? Anyone? Okay. So you just need to use the this type of like polynomial for that. So what is the degree of the polynomial in this case? It should be 3, right? Because there are 4 points. So you have the polynomial will be like this, p3x. So you write 3 here, and it is f at x naught plus x minus x naught, f at x naught x1 plus x minus x naught, x minus x1, f of x naught x1, x2 plus x minus x naught, x minus x1, x minus x2, and then f of x naught, x1, x2, x3. Okay, then in that case, so in this case, this new term is coming, and you should know this just means x3 is just fx1. So what is this? fx2 x3 minus fx naught x1 divided by x3 minus x naught. Okay, and you know what is x2 x3. So once you find p3x, p3 at 0.5, just try to find out what is p3.5 is, and find p3.5 making zero point 0.4 lower by tan 20 and 0.6 low higher by 556. Just find p3 again. Find p3.5 again, updating values. Then just try to find what is your f.3. Change in f.3. Is that clear, everyone? If that's clear, then it's good. Um, and if you have any questions now, you can ask. Here for another 15 to 20 minutes. So I'll show you here. So we have covered today this divided difference and Lagrange polynomial interpolations. We haven't gone through extrapolation. So I think this book is with everyone, right? Just follow this book. This is a nice book. Don't use it, but yes, you can follow this one. So I think next is approximation of functions. We will do that, but yes. If you have any doubts, just let me know.
Excuse me, sir. Good evening.
Yes, yes, Nasir.
Sir, can you complete that problem, sir? The
Yeah,
one which you have just kindly.
yeah. This one?
Yes, yes.
Yes. You want to ask Nasir something?
Yes, sir. Can you complete the solution of this one, sir?
Oh, complete the solution. Okay. All right. I have to. Okay. I just try to solve it then. Okay, this is the hint that I've given. Okay. Yes. So how do you find P3.5? It's just fx naught, right? So fx naught is just your 15. So I label it as x naught, x1, x2, and x3. Okay. Then what is your f of x naught? It's just 15. So I just write 15. X minus x naught. X is your 0.5. Okay. I think you don't need to find 0.3. I think just calculate 0.3. So just because in the question itself it says 0.3. Yes. So 0.3 minus x naught. What is your x naught? X naught is just 0. So it's just 0 into fx naught x1. This is f1 minus f naught divided by x minus x naught. So 0.2, 21 minus 15 divided by 0.2 divided by 0.2. That is your f. Similarly, you go with x minus x naught, x minus x1. So it is just 0.3 minus 0 and 0.3 minus 0.2. I'm just writing it whole so that you can understand it. 0.3 minus 0 and 0.3 minus 0.2 times. Here the things, because it is f x naught, x1, x2, so I would suggest find out these values in before so that you won't feel difficulty. So what is this? Fx naught x1 x2 is basically f2 minus f1 divided by x2 minus x1. So it is 30 minus 21, 0.4 minus 0.2, and minus. Similarly, you just, because you have already calculated this above, you just use this over here, and this 0.4 minus 0. I think it's clear. And then you find out the third equation, which is 0.3 minus 0, 0.3 minus 0.2, and 0.3 minus 0.4. So it is x, yes. And then you have fx naught, x1, x2, x3. So you have already calculated what is called as, wait, I think I have misplaced. So it is x1, x2, x3, and x naught, x1, x2. And you have already calculated what is fx naught, x1, x2. So just calculate what is fx1, x2, x3. So in this case, fx1, x2, x3 is f3 minus f1 divided by x3 minus x1, and f3 is just x2, x3. So f2 x3 minus x2 minus f1 is f2 minus f1 x2 minus x1 divided by x3 minus x1. Okay. So what is f3 in this case? So I just put this directly from above. So I just make a big. So x3 is 0.4 minus 0, right? And you put directly this one over here, whatever is this value, 30 minus 0.4 minus 0.2 minus 21 minus 15 divided by 0.2 and 0.4 minus 0. Okay. And other thing I put it here is this one, this expression. So f3 is basically your 51, and 51 minus 30. Okay, so 51 minus 30.4 minus zero point 0.2, is that zero point 0.3? I think. Wait, I think I'm confused. Yes, yes. Instead of zero point 0.4, you have, yes, here it's clear. Wait, so it's just you have, I think, x0, x1, x2, x2. Yes, zero point 0.4 is there. Here it is. It should be zero point 0.6 because x3 is zero point 0.6. So keep this in mind. Okay, so here should be, it should be zero point 0.6. Here it should be zero point 0.4. Yes, that's true. Yeah. And you calculate it here. So x3 minus x1, x3 minus x2. So zero point 0.6 minus zero point 0.4 minus, and you have f2 minus f1 divided by x2 minus x1, which is, yes, 30 minus 21 divided by zero point 0.4 minus zero point 0.2 and divided by overall x3 minus x1. So x3 minus x1 is zero point 0.6 minus zero point 0.2. So if you solve this, then you will get some expressions which is give you the P2 point. Yes, so which will give you P3.3. Yes. Okay. So you get something like maybe 5.17, kind of anything like that, using this. Now I change this. Now I tweak this because the question says f.4 is lower by 10, right? So you decrease this value by 10. So you just make it 20. Okay. And you make f.5 higher by 6. You make it 56. Okay. Now you do the same thing. Do the same thing and calculate your P3 in the blue one. So P3 will be 6.19, right? I'm I'm not solved it by calculates. You have to solve it. It's calculated. So I just find the difference between. So how does f.3 changes? So that's you have to do. You have to find out RAD P3, the difference between RAD P3 and WP3. That will give you a change. Is that clear? Nasir, is that clear?
Yes, sir. Sir, I have
Oh,
doubt regarding
yes.
this assignment which we had. Uh,
Yeah.
there are two questions. One was on Gauss seidel, and
Yeah.
just for a while, sir, for a while. I'll just open that.
Yeah.
Week 5, the assignment which we had.
Hmm. I don't
For a
have
while,
the
just,
question of assignment.
uh, so actually, question number 3, they gave a system. They said system is ax plus ax is equal to b, but they have given
Yes.
only one a, and they asked the Gauss seidel iteration method converges necessarily for any initial guess. So in option A, they gave matrix A as minus
Hmm.
5, 4, 0, first row,
Minus 540.
4,
Okay.
0. Second row, they have given 0, 4, 2.
Hmm.
Third row is given 3, 3, 6. Sorry, 3, 3, 9. 3,
Yes.
3, 9. That is option A. Option B is matrix A is equal to
Yeah.
row 1, 0, minus 1.
Yes.
Second row is minus half 1 minus 1 by 4. And the third row is
Yeah.
1 minus half and 1. And then
Yes.
option C is both A and B, both the option A and B. Option C, D is neither A and B.
Okay.
So I just went for option only, means I went for option A. Uh, but in key, they have given both A and B. But option B, third row is not diagonally dominant, no, sir.
Third row is not diagonally dominant. Okay.
Second option.
Yes, that's true.
But
Yes.
they have given us both the option A and option C. Sorry, option A and option B.
Okay. It's if it's not diagonally dominant, then you have to check by another way, right? Have you checked?
Which is the other way, sir? Because for any, they said for any choice of initial value, it should converge.
Yes. So
And
if your matrix
converge
is diagonally dominant, then it will absolutely converge. But if your matrix is not diagonally dominant, then you have to check the eigenvalues of that. And
then
if
now
the
I
yeah,
please continue, sir.
if the eigenvalues have the absolute value less than one, then it will converge.
Okay, so we have to check the eigenvalues, and if eigenvalues, all the eigenvalues should be, each of the
The
eigenvalues should be less than one.
absolute value. Yeah.
Okay, if I take the absolute value, it should be less than one. So we have to go for two conditions.
Yeah.
Okay, and one more doubt I had
Yes.
is yeah, math. That was question number 8.
Yeah.
Consider the system Ax is equal to B, where capital A is given as, first row is
Yeah.
1 4A,
One, four.
yeah 4A. Second row is A9. I repeat,
Yes.
first row is only, this is a 2 by 2 matrix, sir. It's a 2 by 2
Okay.
matrix. I repeat, for the first row is 1
Yeah.
and 4 into A. Okay,
I
4
can't
into A.
understand. One, four into E.
4 into A, small a.
Small a. Okay. Okay.
Yeah. And second row is small a,
Yeah.
and the second entry of the second row is 9,
Nine. Okay.
where a is real constant. What is the largest range of a for which Gauss-Jacobi method will converge? I have
Yes.
given answer as mod of 1 by mod of a is less than 1 by 4, but the answer is given as mod of a less than 3 by 2. Can you just let me know? Other than this two, all are very correct. Can you just let me know how is this?
So you have you calculated your what's your iteration matrix in this case? H. What is that?
So for that case, we should also know B, no? But B is not given, no?
It's in that case still you can find out H, right? What is the criteria like? What is the iteration matrix in your Gauss-Seidel method? It's not directly A, so I've just corrected before as well. It's not direct as A. So H is your D plus L, whatever is this, I think. So you need to calculate H and then you have to find out the eigenvalues of H. First H, find H, and find eigenvalues. Have you done that?
Okay, I will just do this also, sir. Okay, I just didn't do this this part. Okay, so and coming to this week assignment,
Yes.
it's always asking up to 2 decimal. And even I have posed this in the question and answer to kindly check once the key, because see, if they're asking 5 iteration, 10 iteration, so surely we are going to take the help of MATLAB and do it. Am I right?
Yes.
For 10 iteration, and MATLAB will not have this precision for 2 decimal in each iteration. After calculating 5 iteration,
Yeah.
only then I have to restrict to 2 decimal. Am I right, sir?
Yes.
So that's the reason I'm requesting once. I posted the message also, but there
Yeah.
was no reply. So I'm requesting you also at least know once the
Yeah.
decimal accuracy up to 2 decimal,
Mhm.
because there are some question they're asking up to 5 iteration, and there are some question they're asking up to 10 iteration,
Tan
and it is
iterations.
asking up to 2 decimal to correct it, round of two decimal.
Okay.
So once I request to kindly check once again after whatever the iteration is
Which
performed.
assignment is that?
Sorry,
Which assignment you are talking about?
I'm talking about assignment 6, which we have to submit on Wednesday. Already I have did the assignment, but
Okay.
the
I will
problem is,
email the first TA who has made the assignment maybe. Yeah.
sorry.
I will email the person who has made the
Please.
assignments.
But I also have sent a mail in question and answer, because up to two decimal there was, and up to two decimal it is going to some other value, which is not in the option. That's the problem. And
Okay.
one
Okay.
option is always the none of this. So since it's
Yeah.
not matching up, so we are forced to go for none of this. So that's the reason
Okay.
I'm simply requesting. Thank you.
I will ask. Yeah.
Answer one last question. Are
Yes.
we, because still the pattern is not clear what we are going to come and write in the month of May? One more thing, should we come with a scientific calculator or normal
Scientific
calculator? Scientific.
thing.
And are we going to have multiple choice question type or essay based question?
It should be multiple choice, multiple select, I think.
But totally 100 questions will be there, no? If it is 100
Yeah.
marks,
Yeah.
is it all will be MCQ and each for 1 mark, 100 marks? How?
Um, it depends. Some may be MSQ. I don't.
Sorry.
Some may be multiple select where you have to select two options.
Okay.
Or what about assignments? Do you find any multiple select questions or
No,
just
no, no. So far,
okay?
it was only single correct.
It would be clearly mentioned if that's the case in the question. So
Okay.
don't worry about it. Yes.
Thank you.
Yeah. Anyone has any doubts? If not, then I will close this session and meet you next tutorial. Have a nice day ahead.